Good day, sir. Today I will discuss the works and function of pump impeller, turbine runner, stator reactor, one-way clutch, and lockup clutch. Pump impeller. An impeller or impeller is a rotor used to increase the pressure and flow of a fluid. It is the opposite of a turbine, which extracts energy from and reduces the pressure of a flowing fluid. An impeller is a rotating component of a centrifugal pump that accelerates fluid outward from the center of rotation, thus transferring energy from the rotor that drives the pump to the fluid being pumped. The velocity achieved by the impeller transfer into pressure when the outward movement of the fluid is confined by the pump casing. An impeller is usually a short cylinder with an open inlet, called an eye, to accept incoming fluid, vanes to push the fluid radially, and splint keyed or threaded bore to accept a drive shaft. It can be cheaper to cast an impeller and its spindle as one piece, rather than separately. This combination is sometimes referred to simply as the rotor. Turbine runner. Turbine runner is located inside the converter case but it's not connected to it. The input shaft of the transmission is attached by splines of the turbine hub when the converter is mounted to the transmission. Many tube vanes are attached to the turbine. The curvature of the vanes is opposite from that of the impeller vanes. Therefore, when the fluid is thrust from the impeller, it is caught in the tube vanes of the turbine and torque is transferred to the transmission input shaft, turning it in the same direction as the engine crankshaft. Before moving onto the next component of the torque converter, we need to examine the fluid coupling whose component we have just described. When first automatic transmission were introduced in the 30s, 40s, the only component were the impeller and turbine. This provided a means of transferring torque from the engine to the transmission and also allowed the vehicle to be stopped in gear while the engine idles. However, these early fluid couplings had the problem of pure acceleration. The engine would labor until the vehicle picked up speed. The problem occurred because the vanes of the impeller and turbines are curved in the opposite direction to the one another. Fluid coming off the turbine is thrust against the impeller in a direction opposite to the engine rotation. Stator or reactor. This is where the stator comes in. The stator sits in the center of the torque converter. This is another series of fan-type blades that are angled so that when the transmission fluid flows into them, it reverses direction again. The stator keeps the transmission fluid, which is turning in the opposite direction of the engine, from hitting the converter housing and slowing it down. Stator is the reaction or torque multiplying element. The stator is the row of small stationary airflows coils attached to the casing of the axial flow turbine, positioned between the rotors. It is designed with blades or ports that can be positioned in such a way that it reverses the direction of fluid flow. The stator is connected to a fixed shaft in transmission. This, along with the blade design, ensures that it cannot split in the same direction of the fluid, but only in the opposite direction, thereby forcing the fluid to reverse direction as it hits Blades of the stator. One-way clutch. One-way clutch automatic transmission have become more and more popular, especially in middle and high-end models. The role of the one-way clutch is mainly to solve the problem of slipping caused by insufficient oil pressure due to the low oil pump speed when the vehicle starts, and to solve the problem of shift shock caused by a mismatch of speed. Although the hydraulic torque converter can play an important role in eliminating the shock of shifting, the one-way clutch automatic transmission is still the most effective way to eliminate the shifting shock, especially in downshifting shock. One-way clutch, commonly known as one-way bearing, is also a mechanical transmission basic part that can only be driven in a single direction or clockwise or counterclockwise. Its function is to make a component only rotate in the certain direction and lock in another direction. When the power source drives the passive element, it can only be driven in single direction. If the power source changes direction, the passive element will automatically separate without generating any power transmission. Lock-up clutch. Lock-up clutch control system is described for an automatic transmission including a torque converter coupled with the output portion on an engine, and the transmitting gear arrangement coupled with the output portion of the torque converter and controlled to vary a transmitting gear ratio therein by a gear ratio control means in accordance with the shifting up or down command supplied to the ladder. A lock-up clutch is provided for locking up the output portion of the torque converter to the output portion of the engine. The lock-up control system comprises lock-up operation control means for controlling the lock-up clutch to be in its operative state and in its inoperative state selectively, and for causing the lock-up clutch to be in the inoperative state thereof when the gear ratio control means performs the control with the shifting up or down command, and lock-up clutch command means for preventing the lock-up operation control means from causing the lock-up clutch to be in the inoperative state thereof until a predetermined reductive variation in the speed of the output portion of the torque converter arises after the shifting up command is applied to the gear ratio control means the condition in which the lock-up clutch is in operation to control a lock-up state. When the lock-up clutch is activated, it rotates together with the impeller and turbine. Engaging and disengaging of the lock-up clutch is determined by the point at which the fluid enters the torque converter. Fluid can either the converter in the front of the lock-up clutch or in the main body of converter behind the lock-up clutch. The difference in pressure on either side of the lock-up clutch determines engagement or disengagement. The fluid used to control the torque converter lockup is also used to remove heat from the converter and transfer it to the engine cooling system through the heat exchanger in the radiator. Control of the hydraulic fluid to the converter is accomplished by the relay valve and signal valve. Both valves are spring located to a position which leaves the clutch in a disengagement position.